Lens with one of its surfaces coated with silver. Lens with one of its surfaces coated with silver. Coated with silver. Lens with one of its surfaces coated with silver. Or effect of silvering. Effect of silvering one of the refracting surfaces of a lens. Effect of silvering one of the refracting surfaces of a lens. What will be the effect of silvering one of the refracting surfaces of a lens? In the diagram, this is a convex lens. In the diagram, this is a convex lens, and this refracting convex surface is coated with silver. This is the second refracting surface. This is the second refracting surface, which is a spherical surface, and there should be silver coating on that spherical surface. A ray is coming from an object point, and this is the incident ray which will be refracted through the first refracting surface, which has focal length f1. Incident ray is incident on the first refracting surface. Incident ray is incident on the first refracting surface of the convex lens. And this is the second refracting surface, which is convex surface coated with silver. This is the second refracting surface. This is the second refracting surface coated with silver, which behaves as concave mirror. And in this case, this is the incident ray which is incident on the first refracting surface. First refracting surface. And this incident ray will be refracted along this path after refraction through the first refracting surface inside the lens. This is the refracted ray inside the lens, and this refracted ray will be incident on the second refracting surface at this point. And this refracting surface, second refracting surface coated with silver, behaves as concave mirror. That's why this ray will be reflected, and it will be reflected along this direction and will be incident again on the refracting surface inside the lens. First refracting surface will have the focal length f1. Fm is the focal length of concave mirror. Fm is the focal length of the concave mirror. We know that second refracting surface or convex surface is coated with silver, which behaves as concave mirror, which has focal length Fm, and reflected ray will be incident on the first refracting surface, and that will have the focal length f1. Now, reciprocal of equivalent focal length, that is 1 by f, is equal to 1 by f1 plus 1 by fm plus 1 by f1 again. And in this case, f1, f is the equivalent focal length. F is the equivalent focal length of the convex lens whose second refracting surface is coated with silver. Therefore, 1 by f is equal to 2 by f1 plus 1 by fm. 2 by f1 plus 1 by fm. In this case, reciprocal of equivalent focal length, that is 1 by f, is equal to 2 by f1 plus 1 by fm. Now, if we illustrate elaborately, then we have to write what? Let the second refracting surface of a biconvex lens, second refracting surface of a biconvex lens be coated with silver, when a ray of light a ray of light, when a ray of light coming from an object point is refracted at the fast refracting surface of a convex lens, at the fast refracting surface of the convex lens of focal length, convex lens of focal length f1, comma, reflected at the second refracting surface, which behaves as concave mirror when it is coated with silver, reflected at the second refracting surface of the lens which is coated with silver, and which behaves as concave mirror, reflected at the second surface coated with silver, which behaves as concave mirror of focal length fm, and again refracted through the fast refracting surface, refracted at the fast refracting surface after coming from the second refracting surface, again refracted at the first refracting surface of the lens of focal length f1, then reciprocal of equivalent focal length, that is 1 by fe. 1 by fe should be equal to 1 by f1 plus 1 by fm plus 1 by f1. 1 by fe should be equal to 1 by f1 plus 1 by fm plus 1 by f1, or comma 1 by fe, that is reciprocal of equivalent focal length of the convex lens with one of its surface coated with silver, that is 1 by fe, is equal to 2 by f1 plus 1 by fm. Refraction occurs twice through the first refracting surface, and reflection occurs from the second refracting surface coated with silver, where fe is the equivalent focal length. Fe is the equivalent focal length of the convex lens with one of its refracting surface coated with silver. When Fe is the equivalent focal length of the lens with one of its refracting spherical surface, and in this case this surface should be second refracting surface with one of its spherical surfaces coated with silver, So finally we get 1 by Fe as equal to 2 by F1 plus 1 by Fm. Now after refraction through the first refracting surface, the ray will come out in the air along this direction. This is the first refracting surface of the biconvex lens, and the second refracting surface is coated with silver, and that convex refracting surface behaves as concave mirror because it is coated with silver. This is the incident ray which is refracted at the first refracting surface which has the focal length f1, and here f1 comes for this term. Reflection occurs from the second reflecting surface, that's why Fm comes here, and again refraction occurs through the first refracting surface. That's why we should consider this term 1 by F1. Now if we consider the biconvex lens, and incident rays coming from left, incident rays traveling towards right, and it will be incident on the biconvex lens. We can denote the poles. P1, P2 are the poles. C1, C2 are the center of curvatures of the lens. O is the optical center. Now we can denote the focus, principal focus of the lens, which will be the midpoint of optical center O, and C1. Mu is the refractive index of the convex lens, we can denote the radius of curvature of first refracting surface. F is the focal length of the biconvex lens. R1 is the radius of curvature of the first refracting surface. R2 is also the radius of curvature of the second refracting surface. If we consider the convex lens without any silver coating, for the convex lens without any silver coating, then reciprocal of focal length of the convex lens, that is 1 by f1, should be equal to mu minus 1 into 1 by r1 minus 1 by r2 using lens maker's formula. Now in the second line we should use sign convention, mu minus 1 under bracket 1 by or comma 1 by f1 is equal to mu minus 1 into 1 by r1 minus of minus 1 by r2. Using sign convention, radius of curvature of first refracting surface, that is r1, should be positive, and radius of curvature of the second refracting surface r2 should be negative. R2 should be minus R2. R1 tends to plus R1 and R2 is minus R2 because R2 is measured in the opposite direction of incident ray. 1 by F1 is equal to mu minus 1 by R1 plus 1 by R2 using sign convention, or comma 1 by F1 is equal to mu minus 1 into 2 by R, where radii of curvature can be assumed as R. R1 equal R and mod R2 is equal to R. Finally, we get the reciprocal of focal length of the biconvex lens, that is 1 by F1 should be equal to mu minus 1 into 2 by R. Now, the second refracting surface of the convex lens is coated with silver, and this second refracting surface coated with silver behaves as concave mirror. But the first refracting surface will behave as a refracting surface of a convex lens having focal length f1, where 1 by f1 is equal to mu minus 1 into 2 by r1. This is the principal axis of the convex lens. We can denote the center of curvature of first refracting surface C1, and C2 is the center of curvature of the second refracting surface. P1 and P2 are the poles of two refracting surfaces. The second refracting surface is being coated with silver. That's why this second refracting surface coated with silver behaves as concave mirror. Now, FM is the focus of the concave mirror. The second refracting surface coated with silver, second refracting convex surface coated with silver behaves as a concave mirror which has focus FM on the left hand side of the lens. Second refracting surface coated with silver behaves as concave mirror of focal length FM. FM, we can denote the focal length of concave mirror. FM is the focal length of the concave mirror. If the focal length of the second refracting surface of the lens, of the convex lens coated with silver or concave mirror, if the focal length of the concave mirror is FM, then FM is equal to R2 divided by 2, where R2 is the radius of curvature of second refracting surface, which is assumed as R. That's why FM should be equal to R by 2. FM equal to R by 2, which is R by 2, half of radius of curvature of the concave mirror. So 1 by FE is the equivalent focal length, is equal to 2 by F1 plus 1 by FM. Putting the expression, we get 2 into mu minus 1 into 2 by R plus 2 by R. Now 2 by R can be taken common under bracket 2 mu minus 1 plus 1 bracket closed. Here this is the convex lens. Principal axis of the lens, second refracting surface is coated with silver. F1 is the focal length of the convex lens, and FM is the focal length of the concave mirror. R1 is equal to R, which is the radius of curvature of first refracting surface. R2 is the radius of curvature of second refracting surface, which is also equal to R. Therefore, 1 by Fe should be equal to 2 into 2 mu minus 1. 2 into 2 mu, 2 bracket open, 2 mu minus 1 whole divided by R, where R is the radius of curvature of the lens. So finally we get 1 by Fe is as equal to 2 into 2 mu minus 1 divided by R. That is the expression of reciprocal of equivalent focal length of convex lens with one of its surface coated with silver, where Fe is the equivalent focal length. Fe is the equivalent focal length of a biconvex lens. Equivalent focal length of a biconvex lens or convex lens with one of its refracting surfaces coated with silver. Convex lens with one of its refracting surfaces coated with silver. Coated with silver. Now we can consider a plano-convex lens whose one surface is convex surface and another surface is plane surface. This is a plano-convex lens where its plane surface, second refracting surface is plane surface, and this plane refracting surface is coated with silver, which behaves as a plane mirror. This is the second refracting surface, which is plane refracting surface. This is the plane refracting surface of a plano-convex lens which is coated with silver. This is the plane surface of the plano-convex lens which is coated with silver, and this is the principal axis of the lens. We can denote a object point, and from this object point our ray is traveling towards the plano-convex lens and which is incident on the first refracting surface. The incident ray is refracting on the first convex refracting surface, and refracted ray will be traveling along this direction inside the lens, and it will be incident on the plane refracting surface which is coated with silver and which behaves as plane mirror. That's why refracted ray inside the lens will be reflected back along this direction. This is the direction of reflected ray which is reflected from the plane surface coated with silver. And first refracting surface has focal length f1, and second refracting surface is plane mirror which has focal length fm. So reciprocal of equivalent focal length, that is 1 by Fe, is equal to 1 by f1 plus 1 by fm plus 1 by f1 is equal to 2 by f1 plus 1 by fm. So we get the reciprocal of equivalent focal length, that is 1 by Fe, should be equal to 2 by f1 plus 1 by fm, where refraction occurs twice and reflection occurs only one time, where focal length of plane mirror is fm, which is infinity. Fm is equal infinity for the plane refracting surface which behaves as plane mirror. And if we consider poles P1, pole P1, and C1 is the center of curvature of first refracting surface, R1 will be the radius of curvature of the first refracting surface. We can denote radius of curvature of second refracting surface. R2 is infinity because second refracting surface is plane surface. So we get 1 by f1 as equal mu minus 1 into 1 by r1 minus 1 by r2 is equal to mu minus 1 by r minus 1 by infinity, where r1 equal r. So finally 1 by f1 is equal to mu minus 1 into r. Therefore 1 by Fe is equal to 2 into mu minus 1 divided by r plus 1 by fm, that is 1 by infinity. Therefore we get the reciprocal of equivalent focal length, that is 1 by Fe, should be equal to 2 into mu minus 1 divided by r. That is the reciprocal of equivalent focal length of a plano-convex lens whose plane refracting surface is coated with silver. For the same case, if we illustrate elaborately, then what we can write? Let the plane refracting surface of a plano-convex lens. Plane refracting surface of a plano-convex lens is be coated with convex lens. It should be not plano-convex surface, plano-convex lens be coated with silver. A plane surface of a plano-convex lens be coated with silver. B is the object point. B is the object point. Here, reciprocal of equivalent focal length FE. 1 by FE is equal to 2 by F1 plus 1 by FM. Where FM is the focal length. Of the second refracting surface or plane refracting surface, which is coated with silver and it behaves as plane mirror. Where FM is the focal length of plane mirror, that is the second refracting surface of the lens coated with silver. 1 by FE is equal to 2 by F1 plus 1 by FM. Where F1 is the focal length of the plano-convex lens without any silver coating. F1 is the focal length. F1 is the focal length of the plano-convex lens. Plano-convex lens without any silver coating. F1 is the focal length of the plano-convex lens without any silver coating, and FE is the focal length with the silver coating. Now, focal length of plane mirror FM is equal to infinity because the second refracting surface coated with silver behaves as plane mirror which has infinite focal length. Also 1 by F1 equal mu minus 1 into 1 by R1 minus 1 by R2 equal mu minus 1 by R minus 1 by infinity. Therefore 1 by F1 is equal to mu minus 1 whole divided by R. Hence 1 by FE is equal to 2 by F1 plus 1 by FM. Semicolon 1 by FE is equal to 2 into mu minus 1 whole divided by R plus 1 by infinity. Therefore, reciprocal of equivalent focal length, that is 1 by FE, is equal to 2 mu minus 1 whole divided by R. 1 by FE is equal to 2 mu minus 1 whole divided by R, where FE is the focal length of the plano-convex lens whose plane surface is coated with silver. This is a plano-convex lens. We should consider plano-convex lens with its convex surface coated with silver. Now the second refracting surface of plano-convex lens, that is the convex surface is coated with silver. There should be silvering of convex surface of plano-convex lens. And this second refracting convex surface is coated with silver. This second refracting surface or convex surface of plano-convex lens is coated with silver. This is the principal axis. of the plano-convex lens. B is the object point from which incident ray will be traveling towards the plano-convex lens. B is the object point from which ray will be traveling towards a plano-convex lens. This is the incident ray which is traveling towards the first refracting surface. Here incident ray is refracted at the plane surface of the lens. It will be refracted along this direction, and the refracted ray inside the lens will be incident on the convex surface coated with silver, and it will be reflected, and it will be again refracted through the first refracting surface along this direction. First refracting surface or plane surface has a focal length f1, and Fm is a focal length of the concave mirror, which is actually the convex surface of the lens coated with silver. Let the convex surface or second refracting surface of a plano-convex lens, Let the convex surface of a plano-convex lens be coated with silver such that the second refracting spherical surface or convex surface coated with silver behaves as a concave mirror such that the second refracting surface that is the convex surface coated with silver behaves as a concave mirror of focal length fm, such that the second refracting surface under bracket convex surface bracket closed behaves as a concave mirror of focal length fm, and the first refracting surface that is the plane surface of the plano-convex lens. First refracting surface that is the plane surface of the plano-convex lens acts as a lens of focal length f1. Therefore, reciprocal of equivalent focal length, that is 1 by fe, is equal to 2 by f1 plus 1 by fm. 1 by fe is equal to 2 by f1 plus 1 by fm. That is the expression of reciprocal of equivalent focal length of plano-convex lens with its convex surface coated with silver. Now focal length of concave mirror fm is equal to R2 divided by 2, where R2 is the radius of curvature of the second refracting surface of the lens, which is equal to R by 2, where we have assumed that R2 as equal R. Fm is equal to R by 2, which is the focal length of concave mirror, that is the focal length of second refracting surface coated with silver. Fm is equal to R by 2, which is equal to R by 2, that is the focal length of concave mirror or second refracting surface or convex refracting surface coated with silver. Fm is equal to R by 2. Now P1 is the pole of the first refracting surface, P2 is the pole of the second refracting surface. We can denote the radius of curvature of first refracting surface. R1 is equal to infinity. R1 is the radius of curvature of the first refracting surface or plane surface. We can denote center of curvature. C2 is the center of curvature of second refracting surface, and we can denote the radius of curvature of second refracting surface, which is R2 equal R. This is the second refracting surface or convex surface, and C2 is the center of curvature. C2 is the center of curvature of second refracting surface or center of curvature. In this case, convex surface is coated with silver, which behaves as concave mirror, of focal length fm. R2 is equal to R, which is the radius of curvature of the second refracting surface of the lens. Now we consider the same plano-convex lens without any silver coating. Mu is the refractive index of the lens. P1 and P2 are the poles of two refracting surface of the lens. Incident ray is traveling towards right. This is the incident ray which will be incident on the first refracting surface. In this case, radius of curvature of first refracting surface is infinity, that is R1 equal infinity. We can denote the center of curvature. C2 is the center of curvature of second refracting surface. Radius of curvature of the second refracting surface is R2, which is equal to R. If we have the plano-convex lens without any silver coating, in that case focal length will be F1. Now we can denote the focal length of the plano convex lens. This is the focal length f2, focus of f2, and we can denote the focal length of plano convex lens. F1 is the focal length of plano convex lens without any silver coating. F1 is the focal length of the plano convex lens without any silver coating. Without any silver coating. According to lens maker's formula, 1 by f1 is equal to mu minus 1 into 1 by r1 minus 1 by r2. Or comma 1 by f1 is equal to mu minus 1 into 1 by plus r1 minus under bracket 1 by minus r2. Using sign convention, r1 is plus r1 and r2 is minus r2. Or comma 1 by f1 is equal to mu minus 1 by r1 plus 1 by r2. Putting the values of r1 and r2, we get 1 by f1 as mu minus 1 into 1 by infinity plus 1 by r. Here we have denoted the radius of curvature of second refracting surface r2 as r. Semicolon 1 by f1 is equal to mu minus 1 whole divided by r. 1 by f1 is equal to mu minus 1 whole divided by r. Therefore, 1 by fe is equal to, it was 2 by f1 plus 1 by fm. Putting the expression of f1, we get 2 mu minus 1 divided by r plus 2 by r. Therefore, 1 by fe is equal to 2 mu divided by r. 1 by fe is equal to 2 mu divided by r. That is the expression of reciprocal of equivalent focal length of the plano convex lens. We get fe as equal r divided by 2 mu. Fe is equal to r divided by 2 mu, which is the focal length or equivalent focal length of plano convex lens. Plano convex lens with its convex surface coated with silver.